Shocking. NASA's James Webb Space Telescope just captured new images of 3I Atlas, and what it revealed has scientists stunned. This interstellar visitor is breaking every rule we thought we knew about comets. Instead of a classic dust tail and water vapor, Webb found a glowing halo larger than Earth, powered almost entirely by carbon dioxide. In this video, we'll unpack Webb's shocking data, reveal how SphereX and Hubble confirm the mystery, and explore what this discovery means for alien worlds beyond our solar system. 1. Webb's unprecedented discovery. When Webb turned its powerful near-infrared spectrograph, NIRSpec, on 3I Atlas on August 6, 2025, astronomers were expecting something similar to earlier interstellar visitors like 2I Borisov. Instead, the telescope delivered one of the most surprising chemical profiles ever recorded. Between 0.6 and 5.3 micrometers, Webb's data showed that the coma, the gaseous envelope around the comet, was not dominated by water, but by carbon dioxide, CO2. This ratio is striking. For typical solar system comets at distances beyond 3 astronomical units from the Sun, water vapor usually dominates, while CO2 and CO act as secondary volatiles. But for 3I Atlas, the CO2 to H2O ratio was 8:1, one of the highest ever seen. The numbers are equally telling. The comet is losing about 129 kilograms of CO2 every second, while water accounts for only 6.6 kilograms per second and carbon monoxide about 14 kilograms per second. This means water makes up barely 5% of the activity, an extremely unusual distribution. The images Webb captured were just as shocking as the chemistry. Instead of the long, dramatic dust tail we normally associate with comets, Webb revealed a glowing halo with almost no visible tail structure. Scientists believe that sunlight was being reflected not off typical fine dust, but off icy grains or fragments escaping from the nucleus. This is a major departure from the standard comet model, where sublimating water ice is the primary driver of visible activity. Why is this important? Because the dominance of CO2 indicates that 3I Atlas likely formed in a very different environment than solar system comets. In our planetary neighborhood, comets typically formed beyond the water ice line, but still close enough for water to be the most abundant ice. By contrast, 3I Atlas seems to have originated far beyond its parent star's CO2 frost line, in regions cold enough for CO2 to dominate over water. This suggests that the chemistry of planetary building blocks in other star systems may be far more diverse than we once believed. Webb's results effectively gave scientists the first detailed chemical fingerprint of an interstellar comet, one that doesn't just add data, but forces us to rethink the rules of comet behavior altogether. 2. SphereX maps a monster halo. Just days after Webb's discovery, NASA's SphereX mission added another layer to the mystery. Between August 8 and 12, 2025, SphereX captured wide-field spectral images of 3I Atlas, offering a broader view than Webb's focused NIRSpec data. What it revealed was jaw-dropping. A colossal CO2 halo stretching 348,000 kilometers from the nucleus, nearly the size of Earth. SphereX confirmed Webb's findings with its own precise measurements. The mission detected intense CO2 signatures, but found almost no water vapor or carbon monoxide. The estimated production rate was around 9.4 times 10 superscript 2 CO2 molecules per second, dwarfing the contribution of water. For context, earlier Swift Observatory ultraviolet data suggested water outgassing at about 40 kilograms per second, but SphereX's upper limit was only 4.5 kilograms per second, effectively negligible compared to the enormous CO2 release. This wasn't just a matter of composition. The structure of the coma itself defied expectations. Normally, comet halos contain both dust and water-driven gas activity. But SphereX showed that 3I Atlas's halo was powered almost exclusively by CO2, with light reflecting not from dust particles, but from icy grains suspended in the gas cloud. This explains the comet's unusually bright and spherical halo with almost no dust tail, a feature nearly unheard of in comets observed within our solar system. SphereX data also offered insights into the nucleus. By analyzing the reflected light at 1 micron, scientists concluded that most of the brightness did not come from the solid nucleus itself, but from the surrounding CO2-rich halo. This means the nucleus could be relatively small, possibly only a few kilometers across, but heavily obscured by its expanding gaseous envelope. Other estimates, depending on assumed reflectivity, suggest a maximum nucleus size of about 46 kilometers. Either way, it's clear that the coma and halo dominate the comet's appearance. Why does this matter? Because it highlights just how alien interstellar comets can be. 3I Atlas isn't simply a bigger or brighter version of local comets. It's chemically and structurally distinct. If such CO2-dominated bodies are common in other planetary systems, then our solar system may represent just one of many different comet blueprints in the galaxy. For planetary science, this discovery is like finding a new dialect in the universal language of cosmic chemistry. SphereX confirmed that 3I Atlas isn't an oddball detail, but a full-blown cosmic anomaly, a reminder that our models of comet behavior need to be expanded to account for interstellar diversity. 3. Hubble, Swift, and the puzzle deepens. While Webb and SphereX dominated headlines, other telescopes added critical pieces to the puzzle of 3I Atlas. The Swift Observatory, using its ultraviolet instruments between July 31st and August 1st, 2025, detected OH emissions, indirect evidence of water vapor, at about 40 kilograms per second. This detection proves that water is present, but it remains a secondary player compared to the comet's overwhelming CO2-driven activity. The Hubble Space Telescope contributed size and structure constraints. On July 21st, 2025, Hubble imaged the comet and revealed activity concentrated on the sunlit side of the nucleus. Its data suggest the nucleus is extremely small, likely less than 2.8 kilometers across, and possibly as small as 0.16 kilometers, depending on how efficiently sublimation drives activity. This means that despite its spectacular halo, the solid body at the core of 3I Atlas could be tiny compared to its gaseous envelope. Ground-based telescopes also weighed in. The SOAR telescope, observing in early July, detected a reddish continuum spectrum, but no common cometary gas emissions like CN or C2. This absence implies that the early outgassing may not have been caused by direct sublimation of surface ices. Instead, it could have been triggered by icy fragments breaking away and releasing volatiles in a less direct process, another deviation from standard comet physics. When you combine all these observations, the picture becomes clear. Webb showed that CO2 is the dominant driver, releasing 129 kilograms per second. SphereX mapped a 348,000 kilometer CO2 halo, confirming the dominance of carbon dioxide. Swift demonstrated that water exists, but at far lower levels than expected. Hubble constrained the nucleus to a surprisingly small size despite the massive coma. SOAR added evidence that the outgassing process itself may be unique, relying on icy grains rather than direct sublimation. Together, these findings point to a comet with an alien origin story. 3I Atlas likely formed billions of years ago in a cold disk far beyond its parent star's CO2 frost line. Its chemistry and activity patterns are unlike anything seen in the solar system, making it a living laboratory for studying the diversity of planetary building blocks across the galaxy. For scientists, the lesson is profound. Interstellar comets are not just rare visitors. They are keys to understanding how planetary systems evolve under conditions radically different from our own. And 3I Atlas is proving that the galaxy's recipe for making comets includes ingredients and methods we are only beginning to grasp. 3I Atlas has gone from a distant curiosity to a cosmic revelation, with Webb's sharp eyes exposing a carbon dioxide-dominated fingerprint, SphereX mapping a colossal halo nearly the size of Earth, and Hubble and Swift confirming a tiny but active nucleus with surprising traces of water. This interstellar comet is rewriting the rules of planetary science. It proves that the galaxy builds comets in ways far stranger and more diverse than we ever imagined. What secrets will the next interstellar visitor reveal? Could even more exotic chemistry be drifting toward us right now? One thing is certain, the story of 3I Atlas is only the beginning. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.